All right, this is worksheet 7.2 washer method, and the first one asks us to take the region that's bounded by x squared plus 1 and the line y equal 10 and to spin that around the x-axis. So first thing we should do is take a look at that region. So x squared plus 1 is a quadratic. 10 comes here. We're going to take that region, we're going to spin it around and have it actually come out. And when it does, it's going to create kind of a ring or donut or a washer. And that's the idea behind this. Some people will call this the ring method or the donut method. It just depends on what you visually see, right? So if I were to kind of make a quick sketch here on our paper, okay, we've got the quadratic coming like this and the line 10 here, and we're spinning this around that axis right there. So when I spin that, if I were to say pick a certain x value here, I'm going to have a large kind of outer part to this that circles around like that, and that large outer part is going to have a radius of 10. That no matter where I am on this part, this big radius is going to be 10. So we'll go capital R, big radius is 10. Now as we spin, there's going to be a piece of this that's missing in the inside, and again it creates what some people see as a washer, some people see as a donut. Again, it's kind of up to you. But that little piece that's missing has its own radius. And in this case, that radius depends on where you're at. It's defined by our function f of x. Right? So our big radius is 10 and our little radius will just be f of x. And so if I wanted to say, forget that I'm taking a whole lot of it, what if I just was going to have the entire thing? Everything then, the total volume, would be the integral from, and these intersect at -3 and at +3. So from -3 to +3, using the disk method, it would be pi times the big radius, 10 squared, dx. So just like we were learning with this method, that would give us everything, as if nothing was missing. But we do have something missing, and the part that's missing, so we'll say the missing piece or the takeaway piece, is going to be the integral from -3 to 3 of pi times that radius squared, which is f of x. All right, so that's the total. That would be everything. We're taking this piece away, so we'll subtract those two, and that'll give us the volume then of what actually would happen if we spun that around. So taking our calculator, I already did this on the top. I did -3 to 3 pi times 100, 10 squared, minus this other one, and I ended up with 1,447.646. Right? And so that's our volume there. So the big trick is really just seeing this big radius and the little radius, right? And so a lot of times you'll see even in a textbook, they'll say go pi times from A to B, big radius squared minus little radius squared, and they'll actually simplify it all the way down to that. And that works too. We certainly could have taken this pi out, put it out front, had it just be 100 minus f of x squared. As you get more comfortable, you could do that, but I know that a lot of times, first starting out, people see it better this way and feel more comfortable writing it that way. So our second one here says let's take the function from 0 to pi that's created by these two here. So we'll go ahead and see what that looks like on our calculator. Let me just unhighlight these, and I'll highlight those. And we're going from 0 to pi. All right, and I think we'll need just a little bit less there and a little bit less there. Let's see if how that looks. I probably should have gone a little higher. So let me do that real quick. All right, so here's the top of it. That's the sine graph going like that, and here comes the cosine graph. All right, we get kind of a spaceship looking thing here in our step. But what we're going to do now is we're going to take this and we're going to rotate it around the line y equal -5. So down in kind of around in here, we have a line, and we're going to take this whole thing, bring it up out of the screen, rotate it down and around and under, and create, again, some type of ring or donut looking thing as we do that. All right, so kind of getting, again, a little bit of a better picture here. We've got this part, the sine graph, and then we have the cosine graph that looks like this, and then we have our line y equal -5 down here that's going to spin around. All right, so I've got a big radius that's going to come and create this big circle. That big radius has this length here, which is the f function. And then we also have added 5 more to it. So the big radius would be f of x plus 5 more. We'll have a piece missing from that. And the piece that's missing from it has a little radius. And its little radius would be g of x plus 5 more. You may wonder, well, why are we adding 5? You know, in some cases, it's going to be less than 5. And if you think about it, in those cases, g of x will be negative. So, you know, whatever g of x's value is here when it's negative, if you added the 5 to it, you'd get the remaining space. We're just talking about the distance at this point. So our little radius, this distance right here, would be whatever that g of x is, and then add the 5, and you'll get that actual value. All right? So to construct this, our volume then would be the integral from 0 to pi of pi times big radius squared f of x plus 5 squared dx minus the part we're taking away, which is pi times g of x plus 5 squared dx. All right? So I have that set and ready to go. Y3 is my f of x. I have that there. And then I went ahead and did that for the y4 for the other one. And if I hit enter, I end up with 525.438. All right, and so washer method, again, can be a little tricky. If you understand disk really well, then it's just another version of disk with taking something out. And this is generally what helps people kind of get through it if they're confused.